Hello again. This time I'm going to look at bivariate analysis. This is where we're looking at data that's paired. And the example I'm going to use is the first one from the text, in which we are looking at a small company that is interested in whether its training program is bearing fruit in its weekly sales. I'm looking at the sample data disk that you can get free from our website. As before, I don't want to spoil this file, so I am going to take the data I need. So I will select it, copy it, and paste it onto a fresh working spreadsheet that's blank. So I've got the data nicely selected now, and all I need to do is go to Charts, and I need what is known as a scatter graph. This will give us a visual impression of what the data is telling us. Now, I don't actually much like what this is doing because I don't like starting the scale at 0. So I'm just going to make a manual adjustment of that. I'll go to Chart Layout, and I will look at axes, and it's the vertical axis that is bothering me. And I need to look at the axis options. And I see that the minimum is set at 0, so I'm going to actually set that to 600 because that's where the data starts. And I think we now get a much better picture. It is quite clear that the data is what we've described as a very strong positive correlation. It runs from bottom left to top right on a fairly narrow band. What I'm going to do now is look at performing the same basic scatter graph analysis on the example where we were looking at staff training and the sales that the staff subsequently achieved. I've begun by adding a page that is in the spreadsheet format, and the data is already entered. Notice that I have also put in headings. I think that this is most important as it's essential to be able to identify where the data is in the calculator's store. I've also added a screen that will show us the graphical statistics of these data. What I've yet to do is tell the calculator where to find the data, and this is where the labeling is important. So I'm going to click to add the X variable, which I'm going to choose is hours, and our points arrange themselves for that variable alone, but we want to compare the hours with the sales. So as a vertical scale, I'm going to add sales. And what happens now is that the data arranges itself into a scatter graph, very like the same analysis done with Excel. And of course, that's what we want. And notice that we've got the same strong positive correlation. The points run from down at the bottom left here, where we have our staff who have the lower amounts of training and the lower sales. And up at the top right, we have the staff who have the higher amount of training and who are, on the evidence, achieving higher sales. In the second part of this section, we were looking at being a bit more precise about whether we have correlations, and also, if we do have strong correlations, what inferences can we draw from the data? There are two issues here. One of them is Pearson's product moment correlation coefficient. That is a terrible mouthful, and it's even worse to actually calculate it unless you have a spreadsheet. Now, what I have done here is, I don't seem to have done much, but I have added a formula, which you can just see here. And the formula that you need to add in is equals Pearson, open bracket. And then I have the first column of data, followed by a comma, and the second column of data, and a close bracket. And Pearson's correlation coefficient is calculated for you. The other thing is fitting a trend line to these, a so-called line of best fit. Again, the calculations behind doing this precisely are very, very time consuming and nasty, And we're very fortunate these days that we can just select from chart layout and trend line. And I'm going to put in a linear trend line. What this means is I am asking the computer to look for the best line to fit through these data. And I'm going to actually ask it also to do a couple of extra things. So I'm going to select trend line options and options here. And the things I'm going to ask for are to display the equation and the value of r squared on the diagram. And there it is, the trend line slotting nicely between the points and the equation of the best line of fit. And actually, for some reason, it gives you r squared, that is the square of this number, but both are very useful. So there it is, and you will see in the text how we carry this equation forward to make some conclusions about these data. Lastly, I'm going to use a graphic calculator to perform these more complex calculations. I've returned to the place that we have left this one off. The only thing I have done is I have added an extra screen that is just a blank calculator screen. So what we need to do is we need to do some calculations now, and the menu will get us there. They're statistical calculations. So I choose statistics followed by statistical calculations, and the type of calculation I need is known as a linear regression. I need to nominate which data I'm doing, and again my labels are essential here. Notice how easy it would be to get yourself in a mess with this. And there are my answers provided for me straight away. As you can see, they are exactly as produced by Excel and as printed in the text. And you should now move on to see what conclusions can be drawn from these more precise calculations.